at SkyView Partners, and I want to welcome you today to our webinar on encrypting data with FIELDPROC, no application changes. We're very happy to have our special guest presenter, Patrick Townsend. Encryption without application or database changes is now possible using FIELDPROC on IBM I v7-R1. Our guest presenter today, Patrick Townsend, will discuss how organizations of all sizes are implementing FIELDPROC encryption, including performance impacts, and how to make sure your FIELDPROC encryption solution will pass a compliance audit. Automatic encryption with FIELDPROC is absolutely the easiest, fastest, and most secure way to encrypt data on the IBM I. Today's session is sponsored by SkyView Partners, and we're happy to have you join us with what was normally Coffee with Carol this morning, Coffee with Patrick. SkyView Partners is a leader in security services and products for the IBM I, AIX, and Linux. So our goal is to draw on the unparalleled expertise of our team of experts led by Carol Woodbury to become team members for our client's IT group, where SkyView pays attention to the security details so our clients can spend time focused on the high-value IT activity that contributes directly to their bottom line. And SkyView Partners is a leader in managed security services. Our presenter this morning, Patrick Townsend, has been in the data security industry for more than 25 years and brings both a deep well of knowledge and unique perspective to the subject. He speaks regularly on data protection and encryption key management topics. As a matter of fact, today's session was presented this year at Common. I think you're going to enjoy it. So with that, I'm going to introduce our presenter this morning, Patrick Townsend. Good morning.
Good morning, and thanks so much for that introduction. I really appreciate it, and glad to be here with SkyView Partners talking about data protection. So let's just jump into this. Let me see if I can get down here. Yeah, our roadmap for today is really to talk about field procedures, or FIELDPROC as we call it, on the IBM I. It's a new facility with v7-R1 of the operating system and is almost always used to implement encryption on the IBM I platform. So we're going to talk about that. We're going to talk about a few new security challenges that come along with FIELDPROC. And of course, if you talk about encryption, you have to talk about encryption key management. So we're going to talk about key management as a component of that. And then just some practical considerations that are involved with deploying a solution to do FIELDPROC encryption on the IBM I platform. So that's our basic roadmap. Just to step back a little bit before we jump in, it's certainly true that data protection or encrypting data at rest is only one part of a larger security strategy in protecting our IBM I platforms. That's why I'm just happy to be here under the auspices of SkyView Partners, because they bring that broader perspective to the table. What I'm going to do is focus on the data protection or encryption part of this today, and how IBM I customers can really effectively implement automatic encryption on the IBM I. So let's start with what is FIELDPROC and how does it work. Well, this is exit point type of technology. If you're familiar with exit points, there are a lot of them on the IBM I. They're fully documented interfaces. You can call them application hooks or interfaces that you can register your applications to and then perform various functions. A lot of them are used for security functions, but that's not their only purpose. With field procedures, which are new in v7-R1, we have the ability to have this exit point within the database itself. In other words, below the layer of the application, so that we can actually implement database functions via FIELDPROC to perform encryption, and no longer have to modify applications to do that. So FIELDPROC was new in v7-R1. It's a strategically supported interface by IBM. It's fully supported in v7-R2, which is now released. And we expect it to be a part of DB2 on the IBM I platform going forward. FIELDPROC is not a new technology on the IBM I. It was introduced on the IBM System Z mainframe in DB2 version 9, so that was some years ago. And the team in Rochester, the database team in Rochester, brought that technology forward to the IBM I platform. There are some little differences between how FIELDPROC is implemented on the mainframe versus the IBM I, but substantially it's the same type of architecture. The exit point, of course, like almost all the exit points on the IBM I platform, does not come with any software to actually handle the exit point. So customers or vendors, third parties, have to bring solutions to take advantage of that exit point. So this is often confusing for people who are approaching automatic encryption with FIELDPROC for the first time. The exit point is there, but the software is not. You either have to write that software yourself, or you have to acquire that from a third party. Before V7R1, encryption, any type of data protection that you would do, was an application software project. You had to identify all of the fields or columns in your database that contained sensitive information. Might have been credit cards or social security numbers or email addresses. Then you had to decide if triggers and SQL views could work for you. That was at best a partial solution. And then you had to identify all of your applications, your RPG or COBOL applications that had to be changed to encrypt data before information was inserted in the database and decrypted when it comes out. You had to then modify all those applications, hoping that you didn't miss any. Then you had to test and test thoroughly to make sure that there were no logic errors and no efforts, no missed applications in your project. So it was a true application software project from start to finish. With V7R1, it becomes dramatically different. It's a database change, not an application change. And so with V7R1 FIELDPROC, we really get a lot of reduction in effort needed to implement encryption. You still have to identify all the fields that you want to encrypt, find the fields or columns in all of your tables with sensitive data. But then you install FIELDPROC exit point software and you activate FIELDPROC on those columns. And we'll talk a little bit more in detail about how that happens and what happens when you do that. But with V7R1, your project then just got amazingly easier. In some cases, we've seen customers with tens of thousands of applications, hundreds of database tables with sensitive data. An application project is really huge. With FIELDPROC, that becomes a much, much smaller and easier project to do. And an awful lot of encryption problems have been resolved along the way. So no database changes are required with FIELDPROC. You don't have to expand the field size for encrypted data. You don't have to change the type of the field. There are no problems with zoned and packed data. Also no problems with date and timestamp type fields, which in many cases actually could not be encrypted under the application approach. Now those problems have been put to rest with FIELDPROC. All of that has just become a lot easier. So very few, for most people, no application changes are required at all. There are some constraints here, limitations around FIELDPROC. We'll talk about those a little bit later. You may need to do a little bit of software reengineering to handle, for example, how encrypted keys behave. But for most customers, for most IBM I customers, the whole process of encrypting columns with sensitive data has become much, much easier. Again, FIELDPROC does not require any change to RPG or COBOL applications, and it therefore becomes very, very straightforward. Again, we will talk about some of the gotchas a little bit later here. So, how does it work? Well, the exit, it's an exit point at the column level in a database file or a table. and you use a SQL statement to implement it. So you can use a create table or alter table statement to specify an attribute on a column. In this example you see here, we're altering the column card no, probably has a credit card number in it, and we're setting the FIELDPROC exit point program to be exit program in prod lib. Of course, you would have your own application name there. And there is an optional constant that can then be passed to the exit point program, the FIELDPROC program, and that can be used, for example, to identify which column it is. Or vendors typically use it for application level control, so they know what encryption keys to use and other aspects about the implementation. So a SQL statement is done this. You cannot implement a FIELDPROC through DDS. And so I know that a lot of folks are using legacy applications where their databases are defined with DDS. You can't implement FIELDPROC through DDS, but you can implement FIELDPROC on files created with DDS. There's some minor constraints there, but they're very trivial. Most people deploying FIELDPROC today to protect data are doing it on files that were created with DDS and are still maintained with DDS. And so SQL is the mechanism by which we install or uninstall the exit point, but it can run, again, on traditional DDS-defined files. Okay, we got this exit point. We got a mechanism to activate it. What do we do with FIELDPROC? Well, you can actually do anything you want. It's an exit point, and you can actually implement almost any application function you want at the column level. When there's a read process, it's going to call FIELDPROC and tell you, I've just read this column and here's the value. What do you want to do with this? Or if you're inserting or updating a record, FIELDPROC gets called again. So typically, encryption is what is being implemented via FIELDPROC. We want to protect that data, and so we're implementing an encryption function at the column level, and of course decryption when it's being read. But other things that can be done with FIELDPROC, well, you could do change control, you could do audit logging, you could do compression if you wished. Again, the exit point itself is neutral. IBM is not providing any software, and if you plug in an exit point program, it can do just about anything you want. But again, what do people want to do in today's environment? Well, they want to protect that data with strong encryption. There are some requirements around FIELDPROC programs. They must be ILE type program objects. They cannot be SQL applications. In other words, they can't contain SQL. If you think about it, this is probably a SQL type of implementation, and the FIELDPROC program can't use SQL to it can't use SQL functions. It can do database I/O. That's not a constraint within a FIELDPROC program, but there is a fundamental constraint that it cannot be a SQL application. And what does it do? Well, it really handles 3 event types, and so a FIELDPROC program must be able to handle 3 type of events that are passed to it. When you first activate FIELDPROC, there's a registration event, and so the FIELDPROC program is going to get called and say, hey, a new FIELDPROC implementation is being added to this column in this table. And you know, do what you want with that. This is a place where a FIELDPROC program itself can do initial setup and definition of how it wants to handle encrypted data. Then, as you might expect, FIELDPROC is called for every write operations. That's an insert or an update, and every read operations on that. So, you know, insert and updates will call FIELDPROC. You're hoping that the FIELDPROC application then will encrypt that data. And every read or select operation, if you're using SQL, will call FIELDPROC to decode it. So those are the 3 events that a FIELDPROC program must handle. So how do they get installed? Well, first you have to create your FIELDPROC program. IBM provides some samples in the Information Center on what that might look like. and you have to install them. So again, you can use, if you're using SQL, you can create a table and specify a FIELDPROC program with its optional constant value on the SQL statement that creates the table. If you have an existing table, and this can actually be, again, a file created with DDS, you can alter that table and set the FIELDPROC program on that column level. Again, it's a column level call, and this will change the attributes. Once you set a FIELDPROC on for a particular field or column, if you do display file field description, you will see that FIELDPROC as an attribute for that field. So you're actually changing the attribute of the field for the FIELDPROC program. Removing a FIELDPROC application program or exit point is also done through SQL, and you simply drop the FIELDPROC definition and it's gone. So these are, again, the ways that these things get done. You might ask yourself, well, do I have to become a SQL expert to use FIELDPROC? If you're using a vendor solution, you probably will never use SQL to implement this. Hopefully the vendor solution will do these interfaces for you under the covers. They'll call the SQL application to set the attribute and enable FIELDPROC, or they'll remove it again. If you're doing it yourself, if you've written your own application, then yes, you have to use SQL to either activate or remove the exit point from the column. So now that we have our FIELDPROC program that we've either written or acquired, and we know how to activate it, and we do activate it, when are FIELDPROC applications actually invoked by DB2 on the IBMI platform? So if we look at in typical insert or update operations, add or update operations, the FIELDPROC will get a call on a row-by-row, column-by-column basis. So if you're using SQL and you do an insert or update or merge, anything that causes a record to be either updated or inserted into the table, FIELDPROC will get called. The same is true with native RPG record level writes and updates. So it doesn't matter. Again, this is an exit point implemented at the database level. So whether you're using RPG or SQL or both, FIELDPROC will work just fine. But any add or update events will call FIELDPROC to encrypt that data. There are some maybe unexpected times when FIELDPROC gets called, queries against the database, and this might be select statements or RPG queries. Will also call FIELDPROC to encrypt the query value before doing a lookup on the database. So this can also include range operations that you might do in RPG. But we now get down to in the weeds a little bit about how FIELDPROC is actually implemented by IBM. And it's quite interesting, and it's quite different than how Microsoft implements column level encryption or TDE in SQL Server, and it's different than how Oracle implements the same in Oracle Database. So with the implementation of FIELDPROC on the IBMI, queries are first encrypted, and then the encrypted value is used to do the lookup. So when you do a chain operation or a where clause within a SQL statement, that value is going to be passed to the FIELDPROC program to be encrypted. And then the search is going to be satisfied using the encrypted value. Again, this logic is quite different than Microsoft SQL Server or Oracle, where the index is first decrypted and then the query is done using the plain text or unencrypted value. So we'll get a little bit into the implications of that later, but that's basically how it happens. If you're using triggers, FIELDPROC processing occurs after, before triggers and before after triggers. This is all in sync, and this is all a part of the IBM implementation. There's nothing that you have to do if you're using, in fact, journaling or triggers in your database. Switching now to read events, SQL selects or any native RPG chain operation or a COBOL read operation on the database, and certain commands at the IBM level will trigger a call to FIELDPROC to do a decryption on the database, on the column. So any kind of read event will again invoke FIELDPROC to do a decryption operation. If you have a table under FIELDPROC control and a column is, a column under FIELDPROC control, and you FTP the file off of the IBM platform, FIELDPROC is going to get called on each read, each record level read, to decrypt that data, and so you're going to have that plain text data processed by FTP. There are some things you can do to put controls around that, but that's the way FIELDPROC works. And we'll talk about a little bit about some additional security controls that you should put in place related to FIELDPROC. What's the one event that is not included on our discussion so far? It's a delete operation. When you do a delete on a record, FIELDPROC is not invoked to do decryption or anything else. So if you do delete a record or you clear a file, FIELDPROC is not invoked to do that decryption. So one common question folks have, and we just touched on this a little while ago, do I have to change my database to SQL? The answer is definitive no. You don't. Most people are implementing FIELDPROC on legacy database tables that were created with DDS. So you do not have to make them SQL tables. You do have to use SQL to activate and deactivate FIELDPROC exit points, but you do not need to convert the tables, and in fact most folks do not do those tables, conversion of those tables. You can if you want to. As IBM has indicated, there are some benefits to converting tables to SQL, both performance and functional improvements, but it's not a requirement to use FIELDPROC. So let's just recap for a moment. What is it and what is it not? Well, what it does is it provides an exit point in the database available to you to be called on insert, read, and update operations on the table, usually to perform encryption or decryption. What is it not? Well, it doesn't provide the actual FIELDPROC program. You have to bring that yourself. It doesn't do encryption for you or decryption. It does not do audit or key management software or provide key management software or solutions. It's strictly an exit point into the story. So IBM has created a door for us, but we have to open that door and go through it and provide the software for the FIELDPROC applications. So you need to provide that software yourself or provide it from a vendor to actually perform the encryption and decryption actions. By the way, if you're not aware, in v7.r2, IBM is providing some new column level access and control features. RCAC is the abbreviation for that. If you're not familiar with that, take a look at that. It is compatible with FIELDPROC. FIELDPROC does not implement RCAC controls, but it's a nice new feature within v7.r2. Is it patchable back to 7.1? Gee, I'm not sure. It may be a part of a technology release, but if you have questions about that, I'll go back and research it. You'll see my email address at the end here. But you should be aware of that too. FIELDPROC, another thing about FIELDPROC is it does not provide additional security controls. You might like to have some additional security controls around FIELDPROC operations, but the database exit, FIELDPROC exit itself, does not provide those. And of course, it's not providing a logging, system level logging of actions for compliance. Those can be, and I believe should be, implemented in your FIELDPROC application, but that's not a part of the exit point itself. So I've been hinting that there are some additional new security concerns around FIELDPROC, and a lot of that has to do with the automatic nature of how FIELDPROC operates. And so when you've implemented FIELDPROC, you've made a positive step forward in protecting data. That data is now encrypted on disk, and it's now encrypted on your backups. And so you have improved your security stance by implementing FIELDPROC. But you, because of its automatic nature, some applications will run and trigger FIELDPROC for decryption. So there's maybe some additional security controls that you might like to have around FIELDPROC. FIELDPROC does not really bring to the table anything that's really additional in the sense of security vulnerabilities. Of course, if it's done badly, it may do that, but by itself, it certainly is an enhancement to your security stance. But you should be aware that its automatic nature means that there are probably some additional things you should do inside your FIELDPROC application to get better control. So some of those additional security controls are user access controls. Which users are allowed to perform decryption activities might be a part of that. You may wish to have automatic masking of data on decryption by policy. If it's a credit card, for example, only those people who have a business need to see a credit card should see the full unencrypted credit card. That's a PCI DSS policy. And so your FIELDPROC applications really should implement masking of data by policy. Other things, we've talked about auditing. The FIELDPROC program really should probably give you the ability to audit records to QAuDjourn, the security journal, which is a proven non-modifiable logging source. And you probably want to, again, to look at DB2 row and column access controls, RCAC, that I mentioned before. So new security concerns with FIELDPROC, and hopefully your FIELDPROC application that you install will help you address these concerns. So what do you need to get FIELDPROC right on your IBM I platform? So obviously there needs to be, hopefully is from a vendor, an easy-to-use management interface. How do you manage implementing FIELDPROC at a column level, and how do you manage deploying the software in the appropriate fashion into your data, into your libraries on your IBM I platform. So getting FIELDPROC right means really being able to manage it appropriately. So you probably want to find or create a user interface that is easy to use, to both install and uninstall FIELDPROC exit points. And it might be nice to have commands. If you have very large databases and you need to run some of these in the background, command type of interface would allow you to do that and to do batch operations. When we talk about encryption, what we often say is that encryption is the hardest part of security, and encryption key management is the hardest part of encryption. So managing encryption keys is fundamental to getting encryption right. That is true within a FIELDPROC environment as well as any place else. And we're going to talk about key management a little bit later. User access controls by policy with group profile support, probably very important. Again, you want to use data masking, and that can be a definite part of those access controls. And group profile support, of course, for all of us who manage applications on the IBM I platform, being able to set policy based on group profiles is very, very helpful. And so you might want to look for that or implement that in your own solution. Audit of activity, typically decryption activity is the most important. It should be built into FIELDPROC. It may be something you activate as an option, but it should be available to you. And again, the IBM Security Audit Journal, QAuDjourn, is a natural repository for audit information. It satisfies PCI DSS and other compliance regulations as a non-modifiable source for log information. And so that's an important component. Lastly, your implementation of encryption, which is typically AES, should be NIST certified or NIST validated, should be provably compliant with industry standards. That compliance with industry standards is a mandate in some compliance regulations and a strong recommendation in others. You're going about your project to protect data to, in some, partly to protect the brand and the reputation of your company. You don't want to implement an AES encryption solution or an other encryption algorithm that is not widely accepted, not proven to meet the industry standards. That'll be a little red-faced moment if you're not doing encryption right. We saw Adobe have one of those moments recently when they weren't using proper techniques with their encryption engine. They were doing encryption and they weren't doing it correctly. So these are some things, the kind of core fundamental things I think you need to get your FIELDPROC implementation right from a technology point of view and from a security best practices point of view. Well, encryption key management is absolutely crucial for compliance. It's crucial for any kind of defensible stance around your encryption strategy. So you don't want to have a data breach where the encryption key is actually sitting next to the data that it's protecting. That is one of those red-faced moments also. So you want to have encryption key management. Encryption key management is a well-defined process by the National Institute of Standards and Technology. Special publication 800-57 is really about key management best practices. They define a number of aspects that should be in place around managing encryption keys through their life cycle. Encryption keys are the secret that have to be protected when you implement encryption. AES itself, an encryption algorithm, is published, public, readily available from a number of sources. It's not the secret. How AES works is well defined via industry standards and readily available. The secret is the encryption key. That encryption key is unique to you and must not be lost, must not be stored with the data that's being protected. And there are, again, best practices and industry standards on how to protect encryption keys. Encryption key management systems are called cryptographic modules in NIST language, and cryptographic modules can be certified to meet NIST requirements, NIST standards, through a process called FIPS 140-2. So Federal Information Processing Standard 140-2 applies to key management systems, and it should be available on any solution that is protecting encryption keys. Again, you're doing encryption to protect data, to protect your customers and employees, to protect the brand and reputation of your company. Getting it right is crucial to achieving those, and you need to have good key management processes in place. Some of the attributes of a good key management solution are that they'll implement dual control, separation of duties, and split knowledge. If you're under PCI compliance requirements, you certainly understand and are familiar with those terms. Key management solutions should also provide for key rotation or key change operations. And a key management solution should be implemented to separate the keys from the data they protect. On the IBM platform or on any platform, HIPAA, for example, is very clear about this. They make a blunt statement. Do not store encryption keys on the server where there is data that needs to be protected. And so it is always a best practice to have physical and logical separation of encryption keys from the data that is being protected. So I know this is new for many IBM customers, the notion that key management, encryption key management is subject to industry standards and compliance regulations, but it's true across the board. Every compliance regulation that you might find yourself under will talk about best practices for key management or have certain requirements in the case of PCI around how you manage encryption keys. In the FIELDPROC environment, this is true too. I mean, the IBM platform is no different than any other platform. When you have a FIELDPROC implementation that's doing encryption, key management needs to be a fundamental component of that. Hackers don't break AES encryption. We know that there have been some press around weak encryption, but AES is well recognized as being if it's implemented properly, and again, NIST validation can help you understand if it's implemented properly. If hackers don't try to brute force break encryption, that is just not done. They find the encryption keys. They either get access to the encryption key management solution, or they get access to the key because it's not protected correctly. With FIELDPROC, key management is again an important fundamental aspect of that. Control of access to the keys, managing them through their life cycle, logging access to keys. Not only logging access to the keys, but logging every single action that is done related to encryption keys. Who creates the key? Who manages the key? How is policy changed around the key? Who retrieved the key? How was it used? All of these are fundamentally important to encryption key management. And because encryption key management is so fundamental to encryption, it becomes a mission-critical component of your encryption strategy. Backup and recovery, managing keys through their life cycle, being able to restore them, all of these are fundamental aspects of encryption key management. With V7R2, we get a little bit of additional security around the onboard master keys that you can create. You can create up to 8 of these. They can then be used to protect data encryption keys in special DB2 tables. You may want to know, again, about these new master key controls. It's an attempt by IBM to address a certain amount of the issues around segregation of duties in managing encryption keys. Prior to V7R2, it simply was not possible to properly implement segregation of duties and dual control because of the ability of QSEC offer, or really any user with all object authority to manage encryption keys. And so with V7R2, we get a step in the right direction. Be careful in terms of how you interpret these new controls. In many cases, it's not segregation of duties that is the problem for managing encryption keys on the IBM I platform. It is dual control. Again, we do get some new capability in V7R2, but you do need to be aware of compliance regulations around this. May not be, I think, probably is not adequate to properly protect encryption keys. Okay, let's change our focus a little bit and talk about some of the practical issues around FIELDPROC. And the first one that typically comes to everybody's mind is, well, what is the performance impact? And how much will it be? So this is a really good question. It should be topmost on your mind when you approach a FIELDPROC application. And how much does it impact performance? Well, that depends. For one thing, AES libraries, encryption libraries, vary greatly in performance. And so if you're using the IBM I native encryption, AES encryption libraries, you need to be aware of potential large impacts on performance. There are solutions that do not bring the same level of performance impact to FIELDPROC, but you need to be aware of them. Key management itself can impact performance. How key management is implemented in FIELDPROC can have a definite impact on the performance of that FIELDPROC operation. And when you implement FIELDPROC encryption on multiple fields in one file, that can escalate the performance issues. It's not a terrible issue in most cases, depending again on how FIELDPROC is implemented and the performance of the FIELDPROC application. But you do need to be aware that as you put more than one column or field under FIELDPROC control, the impact on performance will increase. Again, our recommendation, very strong recommendation, is that you do a proof of concept on your tables in your database. Make sure you're testing FIELDPROC against larger tables. Add enough rows to really emulate production environments and the growth that you expect to see over time, and test that performance. There can be, again, and there are, dramatic differences in performance between one implementation of FIELDPROC and another. And you need to be aware of that, and you need to pay attention to performance. We'd always recommend that you try and do a proof of concept application, put multiple fields under FIELDPROC control, and give it a try. It's very important to do that. Encryption is only one part of the performance impact with FIELDPROC. I know that we're obviously a vendor of FIELDPROC encryption. I'm very happy with the performance of our solution. They're very highly optimized encryption libraries. But that is only one component of the performance impact. The exit point itself and the overhead of the exit point represent an additional impact. And again, you should do your proof of concept and really give it a try. The next area that can be difficult for IBMI customers are implementing FIELDPROC on indexes, fields that are either primary indexes or are part of join files or logical views. And so there are issues with that. Going back to how FIELDPROC works, lookups and queries are done against the database using the encrypted value. Encrypted values are not going to sort in the same fashion as unencrypted values. And so if you're doing a setLL in your RPG code and you're reading a particular range of numbers, that is not going to work the way it typically does with unencrypted data. So you need to be aware of some of these things. FIELDPROC fully supports encrypting indexes. So there's no technology constraint here. You can encrypt columns that are key fields, either primary or secondary keys. And SQL will run and process on those fields, but you need to be aware of some of these constraints. Also, sometimes people ask me, well, what about SQL joins, or what about logical files that do joins? Yes, you can implement FIELDPROC in those kinds of join views on tables. You do have to be sure that you've implemented encryption so that those joins can actually work properly across those logical views or joins. And in order to implement FIELDPROC, you may have to drop that logical view or index before you implement FIELDPROC and then add it in afterwards. But I can tell you that in almost all cases, you'll find that FIELDPROC will be compatible with your implementation of indexes. Again, your applications, you need to make sure that they're going to function properly. In some cases, they may not. But these encrypted indexes is typically where people have issues with FIELDPROC. In 95% of our customers, FIELDPROC works great, does not cause an issue. There's a particular field, like a credit card or a social security number, that needs to get to protected. And this is very straightforward, and this is not an issue, but you do need to be aware of that. Also, I didn't put it on this slide, but it's important to know there was a database group PTF, I think it was database group PTF 28, that addressed some performance issues with FIELDPROC. And so if you're implementing FIELDPROC, be sure you're on the current database group PTF, and at least, I think it's a group PTF 28 for performance. So that was made some great performance improvements in FIELDPROC. Again, I touched on this. The query optimizer can sometimes have impacts on your implementation of FIELDPROC. I've seen people say, hey, I chained to this record that's under FIELDPROC control using a credit card number. I thought it was going to do some masking, but it came back in the clear. Well, you may be a victim of the query optimizer. You can control that. You can turn off some of these aspects of the query optimizer to get the performance behavior or the behavior you want. But sometimes the query optimizer will hand you some interesting results. Those are typically on data masking impacts or audit logging if you're using audit logging in FIELDPROC. So again, practical issues, enterprise key management for folks on the IBMI platform implementing encryption, you typically have multiple applications on multiple platforms. None of us run IBMI alone anymore. We're running Windows, Linux, perhaps mainframe applications. So all of these should fit into a key management strategy. You'll need to protect data across all these platforms. So an enterprise key management solution should address not only IBMI, FIELDPROC implementation issues, but Microsoft SQL Server, Oracle, and everything else that you might need to protect. So again, I mentioned we are a vendor of FIELDPROC and encryption solutions on the IBMI platform. Our solutions are NIST validated. Our key manager is FIPS 140-2 compliant. We've been through that entire process. So customers who need to meet those compliance requirements are completely in alignment with them, with our solutions. And again, our AES encryption is highly optimized for performance. I'm very, very happy with the performance our customers are getting. With our solution, just bar none is the fastest solution available. And again, customers can download and actually take it for a spin from our website. We do provide within our product 2 choices for key management. Some customers will want or have to use a local key store. Others will want a true FIPS 140-2 validated key management. Those are also available from us. And our key manager runs not only as an HSM, but as a cloud HSM, a VMware instance, and cloud instances on Amazon and Microsoft Azure and other cloud platforms. And so, again, we're trying to help IBMI customers address encryption and key management issues, but also we also help Microsoft and other people with other platforms solve those kinds of problems. Let's take a look a little bit at the management interface. Again, there's both a command and a user interface. This gives you just kind of a flavor of what that looks like. You can go right into a user interface and select the fields, add fields to put under column control. Once FIELDPROC is in place, so you can see the attribute on a display FFD, you'll see the field procedure name and the library. And again, you should have access controls around these too. So here's an example of adding a masking access control around a column and it related to a key in a table. And this is done, this masking is done by policy. So we're not looking at object authority, which can be escalated. Privileges can be escalated, again, through users with all object authority. We're using a proper security implementation here using whitelists, and you can define this policy. Auditing also is available to our FIELDPROC customers to really implement that capture, typically of decryption operations, into QAuDjourn. We do have NIST-validated AES encryption libraries. We're the only vendor on the IBMI platform who has taken our encryption libraries through full FIPS validation, AES validation, starting with V5R3 of the operating system, and all those are validated on the IBMI platform. These are, again, our optimized libraries on the IBMI. So as we wrap up, we make evaluations really easy. You can go to TownsendSecurity.com, download our AES solution, put it on your platform, and begin doing that proof of concept. So that wraps up really my prepared remarks around FIELDPROC encryption on the IBMI platform. Again, I'm grateful to the folks over at SkyView Partners for this opportunity to talk about automatic encryption. It's absolutely a wonderful type of technology to help IBMI customers get automatic encryption in place. And so that's it for my prepared remarks. Thank you very much for joining us today.
Thank you, Patrick. I'm going to take the screen back for just a second as we end today's session. If you would like more information, you can contact us here at SkyView Partners or at Townsend Security. And we just want to thank you for joining our session today and wish you all a great day. Thank you again. Goodbye, all.